everyone, and welcome back to my channel. Today we will focus on some laser power supplies. The smaller one was rated at around 300 watt and was removed from a laser tattoo remover. It can do 5 Hz and around 60 joules delivered in each pulse. And the larger power supply is around, maybe I'm not sure how much power it can do, but it was removed from a laser cutting machine, and it can drive 2 lamps independently. 8 huge electrolytic capacitors as the energy reservoir. And here, the charging control conductor, the charging pre-charge resistors, the current limiting inductor, the main control unit, and in its lower case here, there are 2 large IGBT modules in it. Since this power supply is able to do a PWM light intensity modulation at a carrier frequency around 24 kHz for each lamp individually. And this power supply is a little bit heavy for me to just remove it, take it down to show you the inner case. So I will do a video about it later, not today. Today we will focus on this smaller power supply here. Okay. Here is a power input connector, current limiting, rectifier, filtering, capacitors, main switching device. Since this one here, the charging part is just a flyback converter, and here is the main switching unit in the secondary side, thermal sensor, thermal resistor, the firing circuit. This circuit is identical to the firing circuit I used last summer in my 5.5 kilojoules Xenon lamp flasher. The link of the video will be put below. And this is the firing energy storage capacitors, the thyristor, the firing transformer, and this is the auxiliary power supply for the control part of the power supply, and the main control board for such a supply, the communication connector. Here are 2 boards for that larger power supply, and since I am not quite sure about the analog microprocessors, digital processors inside the control board, I just show you guys about this board for someone who may interested in. Quite a lot of components, and it seems that they added this little board here. Fly wire, the same. Okay. And today our topic will also include the Xenon lamps. Here in front of you are 7 post Xenon lamps, and if you look closely, you can see that here, these 2 lamps, these 3 lamps, all have one of their electrode very clear, and another electrode covered with some deposition deposit. So that's why. That's because I was using this connector, this electrode here as a negative connector, negative pole, and that one was connected to the positive side of the power supply. So during the firing process, the positive ion was accelerated toward this end, and they beat strongly onto the negative electrode and caused ionization and oxidation of those elements. And you can see just deposit on the quartz glass. And when you see a lamp has both of its electrode covered with those oxidation materials, oxidate or something else, I don't know. That's because the user used it in a reversed connection and then used it in the normal position, or maybe not a normal position, I mean just he used it and turned it over. Why he does that is because when this happens, the firing voltage will gradually increase, and if your firing circuit is not able to break down the gas, initial discharge, the gas, the lamp won't be fired up. So if you turn it over, change the two poles, you will get easier discharge or firing. And here, this capacitor is the energy reservoir, energy storage capacitor for that small laser power supply. 1.4 kilovolts DC, 100 microfarad, around 60 joules. And one last thing is that I need to get it over to here. Here, I have a very huge laser cavity. This is one of my laser cavities, and it's very strange that it comes with such a cylinder shaped thing. There is another one in my case, but I can't get to it now since I'm shooting a video here. I will show you about it. Here, the full reflective mirror, the Q switch, the crystal, the Q switch crystal, and in another cylinder-shaped case, there is a output coupler and a output mirror to prevent the reflecting laser pulse from the object outside the system. The output mirror has an angle to the center axle that will deflect any reflected light from entering the laser cavity. But I'm not quite sure where or what such a system was used on, and if you know something about that, please tell me. Since this laser cavity, I just bought it for around $80 in a scrap yard, and there wasn't any more information about it, but all the mirrors, the Q switching crystal, the YAG crystal, and a Xenon lamp made in England was in quite a good condition. So I don't know why they tore it down and put it in that scrap yard. I don't know why. And here I have two PDF documentations for you. The first one, the first one here, you can find the details about how to design a laser firing circuit and how to calculate the correct inductor value for the critical damped discharge loop. And I will show you where you can find or get this documentation. This one here is high performance flash and arc lamps for Perkin-Elmer instruments. And here, this one here is a documentation about also many special characteristics about xenon and krypton discharge lamps for laser usage, and the many different types of lamps you may refer to. And this one I will also show you. This is the company's name, and you may find the documentation by search for flash lamps advanced technology. That's all about today's video. Just shoot in a hurry, and I hope you will enjoy it, and maybe you can learn something from it. Thank you, everyone.